be aware that that is always something that you can do. Now, as I said, I wouldn't do it that way. All right, what I see here is we can find the area of the unshaded region because all four of these triangles are the same. We can just go our four triangles times the area of a triangle, so 1/2 AB, and then just simplify this down. All right, that would be 2AB, and those two answers match up. All right, so that does tell you that you can do it either way. So those of you who have done it this longer way, it happens to be the longer way for this one, where you take the area of the whole thing, subtract out the area of the inside part. That still works, and we just showed that based on what we're doing here. All right, any questions there before we get to proofs? All right, so today we're going to do proofs, and most of the time, actually all the time so far, we have tried to find that the two triangles are congruent. This time, we're going to just find that they're similar. All right, now there are different ways to prove that they're congruent. First of all, those different ways for congruency are you can prove it by all the sides being the same. You can prove it by side angle side. You can prove it by angle side angle. And you can prove it by angle angle side. You can also prove it if it's a right triangle. You can prove it by hypotenuse leg and by leg leg. All right, now, if you can prove the two triangles are congruent, then obviously they're similar. But sometimes we just want to prove that they're similar. Now remember, similarity is proven by, first of all the angles being the same, and that is the first one for similarity. Now that's the symbol for similarity, is just one squiggly line there. All right, you can prove it by angle, angle, angle similarity. All right, but that's not the only way. Okay, if you can prove that all of the sides have the same proportion, you can prove it by SSS similarity. You can also prove it by all the rest of these other three based on that also. Okay, so if you only know two sides have the same proportion and you know the angle in between, you can prove that for similarity. Okay, and then these other two, whenever you have two angles, obviously you know the third one, so you could do the similarity for that also. All right, so both of these also work. All right, for a right triangle, you're not ever going to prove that they're similar, because a right triangle, they would be congruent. Okay, so, but you can do the same concept for each one of those. All right, so we're going to try and prove that these two triangles are similar based on one of these 5 things down here. All right, so overall, when I've been looking through your proofs look really good. Just make sure that you take your free points. So it tells us that angle A is congruent to angle E, and that's given. So one thing that I would like you to start doing so that I can see that you're actually doing it, draw a picture on your homework. Okay, mark it up as you go there. Don't mark it up in the book, please. All right, and then we just need to prove that this triangle is similar to this triangle. All right, we don't know anything about the sides, so these 4 are going to be really hard to prove, but we should be able to prove angle, angle, angle here. And the reason for that is we know that this angle is congruent to that angle based on those 2 are vertical. So angle ACB is congruent to angle ECD, based on vertical angles. And that's all you need to tell me. We know the vertical angles have to be congruent. So I'm good with you just saying that. Well, then once we know that two angles are the same, then the third one has to be the same also because they all have to add up to 180. So we can say angle B is congruent to angle D because we know we've got two angles, and that means we know the third one also, okay? And this is just the shorthand for it. If you want to write it out, I already know two angles, the third one has to be congruent. You can write that out too. This is just the shortcut for it, okay? And once we know that the three angles, well, then we know the triangles are similar based on AAA similarity. So we can say triangle ABC is similar to triangle EDC based on AAA similarity. And that's it. That's just a nice short little proof. 4 steps for that one. All right, any questions on that one before we move on here? All right, so the next one. We are given just a little bit of information, and we have to prove once again that the two triangles are similar. So get that stuff copied down, and then we'll go from there. All right, so as we've said in the past, write down your givens, take your free points. We know that AB is parallel to DE, that's given. So then mark that on your picture. All right, so we know those two are parallel. And when we have parallel lines, most of the time we're going to use that. Say that we use this line ACE here. All right, well, this angle and this angle end up being the same because they're alternate interior angles then. So we can say angle A is congruent to angle E based on alternate interiors. All right, well, at the same point, we could do the same thing with B and D here. We could say that those two are the same. So angle B is congruent to angle D based on alternate interiors again. And then there's two different ways to prove that these two angle C's are the same. All right, the easiest would be, I would say vertical angles. All right, but we could also say that since we know two of them, then we know the third one also. All right, now for this one though, we can't just say angle C equals angle C because we have lots of angle C's there. You have to say angle ACB is congruent to angle ECD. All right, and I'm going to say vertical angles. All right, now we know that all three angles in both triangles are congruent. So then we can say that triangle AEC is similar to triangle EDC based on AAA similarity. All right, so a lot of the same concept, just use what you're given. All right, your givens are going to tell you a lot of what's going on here. All right, and especially whenever you have these parallel lines, you're going to be able to prove at least one of your angles in your picture. All right, next one. This one's a little bit harder here. We need to prove that these two triangles are similar. All right, so first thing that we could do here is we could say, well, we know angle A is congruent to angle D because they're both 25 degrees. All right, so that gets us our first angle here. All right, now, most of you probably see that if we went 12 over 6, we'd get a 2, and we'd get 8 over 4 is also a 2. And we could do that, but because of the order here, that actually doesn't work, all right? Because the order of these would be angle, side, side. And that one does not work for congruency. All right, so we cannot just go based on our angles and our two sides here. We have to do something different. And we're gonna have to use something from Algebra 2 that we haven't talked about yet. All right, what I do see here is I see a side and an angle that match up. And then I see another side that we could figure out what angle C is. And that is by using sine law. So we could say sine of 25 over 8 equals sine of C over 12, and that would be based on sine law here. Okay, so we got to do a little math. All right, we would just cross multiply these. We would see sine, let's see, 12 sine of 25 equals 8 sine of C. Now remember, to get C by itself, we're going to have to divide by 8 first. So let me grab my calculator. When we take 12 sine of 25 divided by 8, we end up with approximately 0.64. And then if we take sine inverse of that, we get 39.34 degrees. So then we can say that angle C equals 39.34 degrees based on sine law. Then we can do the same thing down here for angle E. All right, we're going to say sine of 25 over 4 equals sine of E over 6. So same concept, kind of off to the side here. We've got 6 sine of 25, 4 sine of E. We get E all by itself, and we end up with 39.34 again. All right, so we can say down below that, we can say, well, angle E equals 39.34. And both of these would be because of sine law. So then, because these two are the same measurement, we can say that angle C is congruent to angle E based on the same measurement. And now we can mark that on our diagram here. All right, so from here, it's probably easiest to just say that angle B is congruent to angle F. All right, and that would be because we know two angles, then the third one has to match up also. All right, now technically, but instead of doing this point, if you wanted to, you could prove that AB over DF equals BC over EF, And then you could prove it by one of the other ones that has the sides in there. But normally for similarity, if I know that two angles work, I'm just going to say that the third one works, because then we know that the two triangles are similar. And it ends up, this way ends up being shorter most of the time. This is by AAA similarity. All right, so as far as proofs go, this is one of the harder ones in the entire book, and I don't believe you're going to have one of these in the homework assignment, okay? Most of the ones from your homework assignment are going to look more like this one or like this one, okay? But just be aware that you can use sign law to be able to get this stuff done also. All right, and there's nothing in a proof that says that you can't actually go solve one of these angle measurements to be able to prove that the two of them are the same. All right, so any questions on proofs there before we move on? Okay, lesson 18 then. As I said, lots of writing today. You guys have to solve some advanced word problems here. All right, so I'll give you a little bit of time to copy this down. You need to copy these down so you have an example to work off of here. All right, you should have most of it down. All right, now, one thing that you guys have done a very nice job with is most of the time you are in your actual equations here, you're actually using variables that make sense for the actual problem. So you don't actually have to go and define anything. So for example, most of you, for the number of blues, would just put a B down there. The number of whites, you'd put a W, and the number of greens, you just put a G. Okay, and that's totally fine. That's what I do also. Okay, so keep doing that as often as you can. All right, and then most of the time we just need to read each sentence, and that will give us our actual equation. So the number of blues, so B is our equal sign, 4 less than the sum of the whites and the greens. Now less than means subtract, and it means switch the order here. So the sum of the whites and the greens would be W plus G minus 4. Now I put these in parentheses. For this one, it doesn't really matter because there's nothing being multiplied here or anything like that. Sometimes there will be, so just remember, we're going to add those together first and then do whatever you have to after that. Okay, also the number of greens, so G equals the sum of the blues and the whites, so B plus W. Okay, now one thing to also remember, when we have 3 variables here, right, you have to have at least 3 equations to be able to solve this problem. All right, and that third one comes out of the last sentence here. How many of each were there if there were twice as many blues as whites? Now, for this one, we need to think about which one's going to be bigger, the blues or the whites. If there's twice as many blues, the blues are going to be bigger, so we need to take the whites and multiply it by 2 to make them equal to the blues here. All right, so our equations, those would be our three equations. Okay, now there's lots of different ways to do this at this point. I would probably do substitution at this point. All right, and it kind of depends on you which way to go. I would start by plugging this in there for G. So we would have B equals W plus B plus W minus 4. And then I see that my B down here equals 2W, and I can plug that into both of the B's here, and I would just have one equation with a whole bunch of W's in there. All right, so 2W equals W plus 2W plus another W minus 4. All right, and then we just solve for our W here. We have 4 W's on the right side, minus 4, subtract the W's over, negative 2W equals negative 4, divide by negative 2, it looks like our whites equal 2 here. And then once we find this, then we can just plug it into the other ones to be able to solve for like B here. 2 times 2 would give us 4. So our blues is 4. And then our greens, it looks like we add those two together. So we get 6 for greens there. All right, and that would be our answer for that one. All right, so you could do this one very easily by elimination. It all depends on what you see. All right, I just happen to see that you could do substitution pretty easily there. So that's why I did that one. All right, second one, copy it down. It's been a while since we've done any very directly or inversely. So copy it down to get a good example here. All right, now a little review really quick. All right, last year when we talked about varies directly and varies inversely, one thing that I had you guys try and remember was when we set our constant value equal to our variables, directly always meant that you were going to divide your variables in some way. So k equals x over y. All right, if it says inversely, or indirectly, then instead of dividing your variables, you are going to multiply them. All right, and as long as we keep that in mind, this one, to be able to get that equation there, this one doesn't turn into being something too bad then. All right, so we've got varied directly and varies inversely in the same equation. So that's going to be a little joint variation here. But how we get that from here is reds very directly, so we're going to divide, as blues squared, so b squared, and then inversely, so this whole thing is going to be multiplied by the greens. All right, so reds very directly, so divide, blues squared, and then inversely means multiply with the greens, so multiply by G. All right, from there, we need to use our first set of data. We have 80 reds, we have 4 blues, and 2 greens. We just need to solve for our constant value here, our K value. So that would be 80 divided by 16 is 5. 5 times 2 is 10. So our K value here equals 10. All right, and then we're going to use that same equation that we started with to be able to solve for, looks like reds here. So we've got 10 equals R over 8 squared times 10. So if we do the algebra to get R by itself, we're going to divide by 10 first. So we get 1 equals R over 64. Multiply by 64, it looks like R equals 64. And that would be our answer there. All right. I think for the most part, it's just trying to find our equation here. That's normally the hardest part here. All right. Any questions there? All right. Next one. Copy it down, please. And this one is actually a nice little quick one here. All right, now, normally I do not recommend doing this, but a tried and true method of math is you can always guess and check problems. All right, you understand what's going on in the problem. You think, well, I think the answer is this, and then you guess that answer, and then you check to see if it works. All right, now that can be a very frustrating way to do it. But for this problem, that's what I would actually do. I would actually guess and check this because this actually ends up being faster than actually writing the equations out for this. All right, so what we know for sure is we know we're going to have an original number, and when we reverse the digits, we're going to have a new number. All right. Now, what we know about the original number is if we add the 2 digits together, it's going to equal 5. So, first of all, 0.5, that's not a 2-digit number. So we wouldn't use that one. But we could use 14 when we add those together. That'd be 5. 23, 32, 41. Technically, 50 would be a 2-digit number, but when we reverse it, we would end up with a 1-digit number again. So the 50 doesn't work here. All right, now when we reverse these, that 14 becomes 41, 32, 23, and 14. All right, now the answer is on the page already. We just have to figure out when the digits are reversed, the new number is 9 greater than the original number? All right, so the reversal has to be bigger. So these two are gone. And then this one is the one where the reversal is 9 bigger than the original. All right, so the original number would just be a 23 there. Okay, now not a whole lot of math, just a little bit of common sense to do that one. That's how I would honestly recommend doing it. Now, if you wanted to see the equations for it, I'm not going to teach it to you because I think a lot of you are going to end up doing it this way. But if you wanted to look at the equation part of it, it is example 18.4 on page 135. All right. I think for the most part, you guys are going to have the answer from doing it this way before you even write out the equations doing it this way. All right, so that's why I would recommend doing it this way, but it's completely up to you on which way you want to go there. All right, next one. This one you absolutely need to write down. This one ends up being kind of a tricky spot for a lot of kids in the past. So we are going to, what this is talking about is we are going to mix some 20% alcohol solution with an 80% alcohol solution to get a new mixture that's 56%, but we want 1,000 gallons of it, okay? So the things that we don't know here is we don't know how much 20 and we don't know how much 80. And those are going to be our variables here. Now, I'm not going to require you to do it, but I've done enough kind of advanced problems like this where sometimes it's very important to be able to define your variables. Okay, and so I would say I'm going to use X and Y. All right, and what I would say here is I'm going to make the X the 20% and the Y 80%. Now, some of you are going to see this as a waste of time. All right, but what this quickly does for you, if you just write down that little bit, you get all the way through the math part of it. And then by the time you're done, you say, all right, my X was 200. And then you go up here and look, and that tells you that 200 isn't just 200, it's 200 of the 20%. All right, and that's a very important part of your answer here. And then say Y was 800, so it'd be 800 gallons of the 80% solution. All right, if you just put down 200 and 800, that'd be wrong because you got to tell whoever asked you to do this, what is the 200 for? Well, the 200 would be for this 20%. You have to say that. All right, so let's get some equations. We only have 2 variables, so we only need 2 equations. And the first thing that I see is the total is going to be 1,000 here. So when we add these 2 together, it's got to equal 1,000. So that's X plus Y equals 1,000. Normally, that's the easy one to get. Okay. The other one has to do with these percentages in here. And how I like to remember this is when I have the percentages for all 3 of them, it is simply the percent times the amount, it's an X because we don't know how much of the 20%, plus the percent times the amount equals the percent times the amount. So that's the case for all three of these terms here. All right, now for this, I would want to get rid of the decimal here. So if I multiply by 10, it's going to get rid of these decimals, and this one's going to go away because of the 1,000. So I'm going to change this equation here into a 2x when I multiply by 10. 2x plus 8y equals 10 times 0.56 is 5.6, times that would be 5,600. And then I'm set up for elimination here when I multiply the top one by -2. And then add it to this one down here. So -2x minus 2y equals -2,000. All right, the x's eliminate. We get 6y equals 3,600. So then y has to equal 600 here. And if the y equals 600, that means because the total is 1,000, that means the x has to be 400. All right. Now, if I just left it as 600 and 400, that would be wrong because I've got to label this properly. First of all, we know both of them are gallons. And then we've got to say which one is which here. We know the x is 20%, so 400 gallons of 20%. And then the other one would be the 80%. All right, and this would be the correct answer for it with the labels that you need on there. All right, the math doesn't end up being very hard. It just ends up being a little bit of you got to make the equations and then you got to label them up properly. All right, next one. And I believe this is the last one, so get it written down. All right, how many liters of a 64% glycol solution must be added to 77 liters of a 23% glycol solution to get a 42% glycol solution? All right, now we are only asked one thing here. It's how many liters of this one. So we've only got one variable in here. All right, so it's going to be very similar to the last one, where it is the percent times the amount. Well, for the 64%, we don't know how much there. But for the next one, must be added to the 23%. And we know that there's 77 liters there to get a 42% solution. So 0.42 times, now the total for this 0.42 is going to be however much of the 64 we have plus the 23. So the amount for 64 is x plus the 77 for the 23%. And that's our equation with just the one variable there. So we just have to do a little bit of algebra here. 0.64x plus 0.23 times 77 is 1771 equals, and then we got to distribute 0.42x plus 77 times 0.42 is 3234. Then we just need to combine the x's. So I'm going to subtract the 0.42 over. So 0.22x equals, and then we subtract the 1771 over to get 1463. Divide by 0.22, and we get x to equal 66.5 liters of the 64% solution. All right, now technically, because there's only one that they're asking for, you didn't really have to put the 64% on there because that would be assumed based on the question, but it's good to stay in that habit. All right, so you don't miss anything for any of the rest of them. All right, this next one, there's a really good example in the book. I'm just gonna skip that one. I think you guys have enough to work off of for now. All right, and then homework, okay? Lesson 17 and 18, any 25 questions, just remember what we talked about at the beginning of class, where you need to actually do them, you need to show me the work. All right, I don't care which 25 you do. It's totally up to you. All right, this will be due on Friday. All right, so unless you have any questions for me, I'm gonna let you go. Any questions at all, people? Okay, I will see you on Wednesday then. You guys have a good rest of the day.